Hello everyone, today we are solving LeetCode daily problem number 960, delete columns to make it sorted, part 3. It is hard problem mainly because it's connected with the DP topic. Okay, so let's take a look at the problem. We are given n strings, each having the same length, let's call it m. We need to choose a smallest possible set of indices such that when we remove the characters at those positions in each of the strings, the remaining strings would be sorted. Let's see this in action. In the example on the screen, we are given 5 strings, each having length 6, so we can view this as 5 by 6 matrix. In this matrix, we can remove the second, fourth and fifth column, so totally we are doing 3 operations, and the newly formed strings are all sorted. In a case of just one string, the problem is basically to find the length of the longest increasing subsequence of the given string. In the example on the screen, the length of that subsequence is 3. So now the question is, how can we find the length of the longest increasing subsequence for a given array of characters or numbers? In this example array, the length of the longest increasing subsequence is 5, but note that there are multiple solutions with the same length, but for this problem, we don't need to consider them. This is a very standard DP approach problem. We will define DP of I to be the length of the longest increasing subsequence ending with the element I. In the example, the length of the longest increasing subsequence ending with the element on position 13 is 8. That's why DP of 13 is 8. For position 11, DP of 11 is 4. Now let's see how can we calculate DP of I. We would assume that we have calculated DP values for each position before I. Now the trick is to consider element j that can come before I. Since we know that the length of the longest increasing subsequence ending at j is, we can combine that to get a new increasing subsequence ending at I. We do this for every j and keep the maximum length found so far in DP of I. I want you to notice that we can write our own custom comparator such that we can tell if j can come before I. The last trick to solve the problem is to consider each column as one element. Obviously, we cannot yet quantify each element to some number and tell if one column is less than another column. But if we take two columns and inspect them, let's say column 3 and 5, and check them row by row, we can definitely tell that column 3 can come before column 5. Let's look at another pair. If we take, let's say, column 1 and 3, we can see that the column 1 cannot come before column 3. So, in a sense, everything comes down to our custom comparator. So, combining that comparator with the previously shown DP code, we get fully functional solution to the problem. If you found this video helpful, please consider liking and upvoting. Thank you.